Today is January 31st, 2017, 12 days after I filled my vial with saturated alum solution. As you can see, my vial still does not contain crystals. If you look closely, the base of the vial has formed a few objects that look similar to small snowflakes. These objects could be the nucleus of a new crystal, so I'll be able to tell whether or not they are in a few days. There are a few environmental factors that could be affecting the crystal growth. First, the day after I took the last video, I changed the Chem wipe on top so that it was a single layer instead of a triple layer to improve the Chem wipe's breathability. In hindsight, this could have agitated the system and could have undone any small crystalline growth that may have occurred. Additionally, my vial is on my windowsill, about 5 inches away from a lava lamp. I put my vial far away from the lamp to keep heat from the lamp from being transferred to it. However, small amounts of heat might be entering the system and disrupting the crystal growth. I will rectify this by moving my lamp away and keeping the extra heat from entering the system. Before starting the reaction, we obtained a portion of aluminum foil and found its mass to be 1.035 grams. To find the theoretical yield, I referenced the chemical equation pictured and a periodic table. I first found the molar mass of aluminum so that I could convert the initial mass quantity into moles. I then consulted the chemical equation to find the required mole ratio between aluminum and alum, which was determined to be 1:1. I then found the molar mass of alum by using the mass values on the periodic table and used a calculated value of 474 grams per mole to convert the final value into grams of alum. After running this calculation, I determined that the theoretical yield of the solid alum is 18.2 grams. The equation to find the percent yield is actual yield divided by theoretical yield times 100. The mass of our synthesized alum, or the experimental yield, was found to be 16 grams. I then plugged these values into the equation to find that our percent yield was 87.9%. Our experimental yield was not exactly 100%. This could be because of a couple reasons. First, during the lab, we removed the beaker containing the alum from the ice bath prematurely because we were only trying to make about 5 grams of solid alum. Once we thought that there was enough precipitate visually, we filtered the solution and consequently halted the precipitation of solid alum. As a result, if we had left the beaker in the ice water for a longer period of time, we may have yielded a higher mass of solid alum. Another reason that could have reduced the amount of alum that we yielded is that some of the solid may have dissociated when it was washed with the ethanol and water mixture. When this liquid was poured over the solid alum, some of the solid molecules may have been hit by a liquid molecule in just the right way to cleave the solid molecule off. If this happened many times, this would reduce the final mass of the solid. A final reason for why the experimental yield is not 100% is that some of this precipitate may have been stuck to the Buchner funnel when we were trying to empty all of the solid onto the scale. The residual solid stuck to the funnel would add to the mass and would increase the percent yield if we had been able to empty it correctly.